Today I wanted to talk to you about the ocean currents lab. So what we're going to do is I'm going to show you how to get to the lab, and then we'll kind of work through it. So there's a couple ways to get to the lab. The first is to go to course materials, click on content, and then click on the physical oceanography module and just click through the pages until you get to the ocean currents lab. The other way to get to it is to just click on this pink physical oceanography button and then scroll down till you see that assignment. So this is not this one, it says not graded, so it's not this one, it's this lab, ocean currents and temperature. So on this one, it has the link to the handout, and it also says it's on page 6 of the module. So if you need some more help with like the background information that you need to put in your introduction or something like that, page 6 of the module would be a great place to go, because there might be some of that information on that page. So let's go ahead and let's click on that and see what happens. Okay, it gives me a document. Okay, so let's see what we've got going on here with this lab. So this one says some water in the ocean is cold, some is hot. What would you expect to find the coldest water, or just plain cold water? Where would you expect to find warm water? Do hot and cold water mix? Okay, so basically we're going to need a lab report. So what I'm going to do is I'm going to start my lab report down here. Okay. So for this one, to get this information, you might want to look at your content, look at the module. Okay, so if we were to go back here and we were to go to course materials, click on content, go to physical oceanography, click on physical oceanography. Let's see what's on page 6. Okay, so let's look. Okay, so here's greenhouse effect and global warming, and on this page there's climate. Okay, so this is going to tell us about cold and hot water, where warm water is located, where cold is water located. It'll talk to us about whether cold and warm water mix, hint that's the thermocline. So we can find a lot of this information in our content, but if we need to, we can research as well. You can research online, wherever you want to go. Okay, so that's just a hint of kind of where to go to find some of the information you need for your introduction. And then once you have that introduction, whatever sources you've used, you'll want to use that at the end. So let's say I use this page. I would take this link and I would say something like Gav's Oceanography and then put the link or something like that. It doesn't have to be super detailed. I don't really need APA or MLA. If you want to use it, you can. But I would just write something like that. So I've gone ahead and I made a section for my sources while I'm working on my report. Okay. The next thing I want to do is I need to have a materials and methods section in my lab report. So I'm going to, okay, so you want to list your materials and write a procedure. Now here's the kicker. You want your procedure to be detailed enough that someone else could follow your assignment, or someone could follow your procedure. But should not be copied directly from the handout. Okay, so here's what's not to do. Don't just take this right here and copy and paste it down here. You'll lose points. You won't get points for that. Okay, I want it in your own words. You can number it if you want. It doesn't have to be paragraph form. Okay, the introduction should be in paragraph form. Okay, the materials and methods section does not need to be in paragraph form. Okay, let's see our next section. Let's see what we've got going on. Okay, so the next thing we need is we need our results or our data, right? So we'll develop a hypothesis as to how the water is moving. Okay, you want to write your hypothesis here. Okay. Remember, hypothesis should be in an if-then format, okay? So here's an example. If I do this, then this will happen. Okay? The thing that you're doing, if I do this, that part is, this is your independent variable, then this will happen, that's your dependent variable, whatever is changing in response to that independent variable or that thing you did basically before the comma on your hypothesis. And then whatever happens after the comma on your hypothesis, that's your dependent variable. Okay, so we're mixing ice, cold water, food coloring. We're going to fill a glass with hot water. We'll use a clear straw. We'll place some ice water on top of the warm water. Observe what happens. Using the straw, place some ice water below the warm water. Observe what happens. Okay, so here's what we're going to do. For your results, they're going to want qualitative and quantitative. So qualitative is like words, observations. There's not really numbers in your qualitative observations. There's going to be numbers in here, okay? So some qualitative observations, right? You might say it got larger or smaller. How the ice moved. How the water moved. Things that you notice while you're doing your experiment. Your qualitative would be in numbers, so you could say, you could measure measure the initial size of an ice cube and then measure the, the after size of an ice cube, after you put hot water on it. You could measure the temperature of the water. Something like that. You have to have something with numbers, okay, to be qualitative data. Okay. So now let's go to our analysis and conclusion section. In your analysis, you're going to want to answer these questions. Okay. Oh, I thought of another qualitative. You could discuss how and where the blue water moved. Okay, that could be another really good qualitative observation. Okay, I'm gonna make sure we did everything in our results. Okay, so we need to draw a picture of what happened during the experiment. Okay, so you'll have your qualitative observations, and then you'll have some sort of picture of what happened. Okay. So these questions, these 6 questions, are things that you'll answer. Adding cold water on top, did that produce a current? Did the bottom produce a current? Define convection. Infer why the current that you created during the lab is called a convection current. How does the experiment demonstrate water density? Was your hypothesis supported or refuted? Why? Explain. You don't just say it was supported or refuted, say why. Okay, and what might this experiment be useful in the study of the ocean? So how can we apply this to the real world? Okay, so I'll make a couple notes here. How can we apply this experiment to the real world? I'm just going to highlight this explain because I feel like that's pretty important. Define convection. Water density. Okay, I think that's good. let's see, and then you're going to want to have a conclusion. So you want to write a 4 to 5 sentence paragraph detailing if your hypothesis was correct or incorrect, what you learned by the lab, and anything you would do different in the future, and how it relates to our study of the ocean. So hopefully your questions from the analysis section help you write your conclusions. So they might kind of give you an idea of what you want to discuss during your conclusion. Okay, and then if you added any references during the conclusion, you would add those as well. You know, whatever you want to put in here. Your title, if you want to make it really fancy, you'll do that, and then you'll say bye, and then your name. Your title should be descriptive, relate to the lab. Okay, you just don't want to call it like lab. Okay, something that gives us an idea of what we're talking about here. And then this is basically the format for your lab report. This one was pretty straightforward, I think. Hopefully the actual lab that you guys do like at your house will be pretty interesting. And I'm going to go ahead and put this document right here. I will put it right here in the lab ocean currents and temperature section. I'll link to it so you guys can download it and kind of put your information in here. And then I'll put this video in here as well. So hopefully that was helpful.